third variable in interpreting multiple regression. Again, I've suggested that you follow along using this text lecture. Read it once first, and then follow along using this so I don't have to switch back and forth between SPSS. So we've already gone over how to get the output, how to figure out whether or not it's significant by using the p-value. Then we interpreted the unstandardized coefficients. And then what I'd like to show you now is the standardized coefficient, or what SPSS calls beta. Okay. So here I am right here. This is the section that I'm going to go. So here are the two standardized coefficients. This allows us to see which of the independent variables has a greater effect on the overall model. Okay, and so what you do is you'd put them in order. Again, you'd need both of these to be significant for this to be meaningful. As we found out in the last video, that's 0.036, less than 0.05. 3.6% is less than 5%, so this is significant. This is the equivalent of 16.9%, which is greater than 5%, so it's not significant. But we're going to play make-believe here, okay, and pretend that they are both significant. So we say, which of these has the greatest effect on monthly income? Is it age or gender? Again, you're going to need to read all of this for this stuff to make sense, because I try to keep these videos short. If you're not going to read this and you're just going to listen to this video, you're going to, unfortunately, probably going to be quite confused. Okay, so basically you would put them in order. Okay, 0.351 is a bigger number than 0.226. Okay, so we'd say in this case, pretending they're both statistically significant, age has the greatest effect of the two independent variables on income. Again, really remember, age is the only one with an effect. Okay, interpreting the standardized slopes or coefficients, or beta, is kind of wacky because it uses the language of standard deviations. Remember, a standard deviation is nothing more, on average, how much do all these data points differ from the mean? Okay, so I ask you to interpret one of these on the exam. Let's use age, because it is actually meaningful, because it's statistically significant. The sign is important here. Notice that there's no minus sign up there, so that's important. It's a positive, so that means it has a positive effect on income. Okay, so here's what it means right here. When all other independent variables are held constant, for every increase of 1 standard deviation in age, there is a 0.351 standard deviation increase in monthly income. Okay, so that's what that means in plain English. I do essentially the same thing for gender. It's a little bit different because it's a dummy variable. So it says female as compared to male, as opposed to every 1 year increase, or excuse me, 1 standard deviation increase, because that's ratio. So you're going to have to read this fairly closely. But again, since gender is not significant, I use that funky language that I talked about in the previous video. Okay, so if either one of you're asked to pick one of these two on the exam. If both are significant, no problem. But if neither one of them is significant, meaning your p-values here are too high, greater than 0.05, just use this little formula right here, as I've done in the example. Okay? Alrighty, that's the end of the video.